For 2.5, we're going to manipulate a formula or equation in order to solve it for a particular variable. So we also call these literal equations. They're made up of multiple letters and possibly numbers, and you'll be asked to solve for one of the specific variables in the equation. So the steps are to first locate the variable you are being asked to find. Then use your inverse operations as if you were solving like any other equation to get the variable alone. So for each literal equation, we're going to practice a similar equation that only has one variable so that we can understand that process for the literal equation. So first, let's review. If we have a one-step problem like 10 equals 5x, we would want to isolate the variable x by dividing 5 from both sides, leaving us with a solution of 2 equals x. The literal equation to the right looks very similar. You have 3 parts. So the c is sort of like the 10, the pi is like the 5, and the d is your variable x. This problem says we're going to solve for d. So, just like our first equation, we would want to divide the number in front of it, which happens to be the symbol pi. And we have to do that on both sides. So that eliminates pi from d. So we've gotten the variable isolated that we were asked to solve for. On the left side, c, a variable, cannot be divided by pi, and so it's going to remain looking like a formula, just in a different order now. So this is our final solution for this literal equation. We still got a variable isolated, but we couldn't reduce our division because we don't have numbers. For example 2, our goal is to get the x isolated. So let's start by multiplying 5 from the division. Since 8x is grouped up with the 4 in the top, we want to get rid of that single 5 first. And that means we need to divide the other side by 5, using our property of equality. So 5 times 4 is 20, and then we have 4 minus 8x left on the other side. To solve for the x, we would need to subtract 4 from both sides, giving us 16 equals negative 8x. Still needing to isolate the x, we would divide by negative 8 on both sides. So 16 divided by negative 8 is 2, and that is equal to the x. So just to note, we had to start with multiplication, and then we use subtraction, followed by division to reach the solution for x. It helps to note it that way so that when we go apply the same process to a similar literal equation, we can follow those steps. If you noticed in our equation, x was in the numerator after the coefficient of 8. The variable we want to solve for this time is e, and it's in the same position as that x was in the numerator after the coefficient negative 10. So if we want to get that e alone, we're going to follow similar steps that we followed from the first equation. We need to get the denominator m out, meaning instead of it being divided, let's multiply it to both sides. Well, m and s cannot really be multiplied to create something new, but we can just set them up next to each other because 2 letters next to each other means multiplication. So we have ms equal to w minus 10e. So we took care of that multiplication step. Now we want to use subtraction because we need to move this w away from the e. Since w is positive, subtract it from both sides. W is not the same variable as ms, so it's going to stay as a formula, ms, still multiplied by each other, minus the new w, equal to negative 10e. So everything from the right side is just moving over with the opposite operation to the left side. So we got rid of the positive w by subtracting it away. Now we need to use division because we don't want negative 10 to be multiplied by e anymore. On the left side, we can divide the entire expression by negative 10. And so this second box leaves us with ms minus w. Since those are variables, they can't really be divided by a number of -10, and that is equal to our e. So box 4, if you label these out, we had box 1, box 2, box 3. So box 4 was very similar to box 3 if you followed the same steps as we showed. And now let's look at example 5, and then we'll end with example 6, which is going to be similar to 5. First, in example 5, we want to subtract 10 to start isolating x on the left side. Then we can end with division because 5 is multiplied by x divided away and divided on both sides. The problem for number 6 looks pretty similar. We have multiple variables this time, but the goal is to get the y by itself. And if you look, y is in the same position as x was in our previous problem. So to get that y alone, let's move the 3x. We would subtract 3x from both sides of the equation, leaving us with 5y, which is almost now isolated for y. Since 15 does not have an x on it, it has to stay as -15 and still minus 3x. They are not like terms, so we cannot really combine them. We just set them up next to each other. And now we can divide both sides by 5 in order to get y alone. So we have -15 minus 3x divided by 5. We could actually take that answer one step further, as we could have with our e equation. We can split that answer into two parts. We would have the y equals. First, we would take -15 divided by 5, and then -3x also divided by 5. And we could reduce -15 divided by 5 to get -3, but we cannot reduce the fraction of -3 over 5. So that's just another way you could write this solution. And when we get into Unit 3, we'll be writing linear equations from standard form, which you would see up here in box 6, to slope-intercept form down here at the end of our solution. But at this point, both answer forms would be acceptable. So we're going to do a couple more literal equations where we don't have an example worked out the same way as the literal equation. So really focus on where you want to start or what variable you're interested in isolating. So for number 1, we're trying to get b isolated. So b is going to stay right where it is, meaning the mx need to be taken away. Well, the whole product mx is being added to b. So we're going to subtract the mx to the other side. But y is a different variable than mx, and so it can't really be subtracted with it. So the y stays, and the mx comes over as a negative, cancels out from the right side, leaving us with just b. And now the equation has b isolated. For example 2, our goal is going to be to get y by itself. So let's move ax away from the by first. Since the ax is positive, we're going to subtract it to both sides, canceling it from the left, leaving by, and then it's going to have to stay c minus ax because those are not like terms. We still need y to be isolated, so we're going to divide by the b. And you can divide the entire expression by b, leaving you with y equals c minus ax over b. If you wanted to split that answer up, your right side would have c divided by b and -ax divided by b. That would be the other way to write that answer. For problem 3, we're going to isolate the y, which means we got to get rid of the positive 3x first. So let's leave -5y, and the only way to undo 3x is subtract it. So I'm going to show that work that I'm subtracting 3x from both sides. So the 5y is still negative and stays on the left side of the equal sign, but the 3x has now been subtracted on the right side. Because 3 has an x and 10 does not, those terms can't be combined. We still need to isolate y, so we need to divide both sides by negative 5. Y is now on its own, and we can keep the answer as 10 minus 3x over 5, or you could split it to 10 over 5 minus 3x over 5, reducing 10 over 5, but not able to reduce the other fraction. So this would be another acceptable way to write the answer. In problem 4, the goal is to get B2 isolated. It's in the parentheses, but we're actually not going to distribute because that's just going to cause more value to the B2. And it's already a B2 on its own, just with things around it. It doesn't have a coefficient, so we want to leave it like that. So first, let's get rid of this division of 2 by multiplying 2 on both sides. 2 times a can just be left as 2a. And then we're left with h times b1 plus b2 on the right side. The h is being multiplied by all of the parentheses, so just divide it off of the parentheses to the left side of the equation. 2a cannot really divide by h, so we're going to leave it looking like division. And now that there's just 2 terms left in the parentheses, we don't even need the parentheses to put b1 plus b2. So now all we have to worry about is moving that variable b1. The 1 is attached to it, it's called a subscript. So if I still want to get b2 isolated, this positive b1 needs to be subtracted on both sides. So 2a was divided by h, and now that side is subtracting b1 to give us an answer of b2. You'll be finding literal equations are common, like I said, in Unit 3 when we start graphing linear equations, and we need to move the formulas around. You'll also see it with geometry when you're trying to solve for a certain element of a shape, like a polygon. So for example, this is how to find the area of a trapezoid, and maybe you specifically really just need to find base 2 instead of the area, so you would plug everything back to this side of the formula. So continue to practice your literal equations here in the 2.5 practice. Make sure to show all your work, circle your final answers.